Hello student of, hello student of class 8. Once again I am Sudhir and welcome to my video. And today in my video I will show you the solutions of exercise 6.3. So in the previous video I have shown you how to find out the square root of a number with different methods, isn't it? So there are altogether three methods are there. One is called uh, method called limited subtraction, where prime factorization and division methods are there. So division method is not coming yet, but it will come in the later on the chapter. But now we are dealing with to find the square root by the methods called repeating subtraction and prime factorization. So now let us go to exercise 6.3, and in 6.3 question number 1 we have here, we have to find out the number which is possible in one digit of the square root. See, two numbers are given, not only two numbers, some numbers are there. I just try to show you for only two questions here, one and 2. Okay, so the rest you try yourself. See, we have to find out the possible one digit. Possible one digit means in the square root of this number, they are the square number and they will have the square root. So the square root of this number will have 2 or 3 digits, maybe, we don't know, but there will be some more digits. They are like 2 digits or 4 digits, but we have to tell them what is the possible number in the ones digit. What is the possible number in the ones digit? Okay, clear? So what happened? Only just to mention that the last digit of this number number 1, what will be the last digit of the square root? So a square root will be there for this number, that is 9801. So what is the possible one digit here? Okay, you see what is the number in the ones place of this number? In the ones place, the number is 1. So what happened? Because of 1 is there in the last digit of this number, so the last digit or the digit in the ones place of the square root also will be 1. The possible is 1 because 1 square means if we just take the square of this 1 square will be 1. So 1 is a possible number in the ones digit of this square of the square root of this number. Once again, 1 is the possible number in the last digit of the square root of this number given here. Why? Because 1 is here in the last digit, isn't it? Yes. So the answer is 1. Yes. The answer is 1. So 1 is the possible digit in the last digit of the square root. Next, let us see. Now just see what is the last number here. The last number is 6. So what could be the possible digit in the last number, or digit in the last number, or digit in the ones place of the square root? So in the square root also, just you take this 6 into 6 is 6. 36, isn't it? So 6 is a possible digit in the last digit of the square root again. Okay, so we just consider the last digit and we can just assume that, we can just tell that what will be the last digit of the square root. So that the last digit of the square root of this number also could be 6. Not 6 is not the square root, but 6 will be, or 6 is the possible number that will be the last digit of the square root. That's all. How we find out? We just take the square root of the last digit. 6 is 36. Okay. For example, if there is 4, then 4 is 16. Again, 6 also will be. Isn't it? If it is 5, then 525 to 5. 5 is the possible number in the ones digit, like this. Okay, clear? So let us go to the question number 2. And the question number 2 is very simple. And in the question number 2, what we have to do is that without the calculation, you have to tell that what will be the without doing any calculation, find the numbers which are surely not perfect square. So in question number 2, you have to tell that whether the given numbers out of this given number or among the given numbers which are the perfect square and which are imperfect square. To see whether the number is a perfect square or not, we have to consider the last digit. If the last digit is a digit, then that digit is possible for the square root or not. Understand? I mean, that could be make the number as a perfect square or not. See, we have studied, I have told you in the beginning of the chapter that which type of number, okay, having the last digit could be the perfect square or not. So we have to refer that point. So by that, you can tell these 2, 3, 4 numbers are there. So you can easily tell them that which one is a perfect square or not. No need to calculate, no need to see, but you can see the last digit. If the last digit is ending by some type of number, some kind of number, okay, then that number which is can give the idea, can give the message that a number could be the perfect square or not. Then that number having the last digit. For example, let us say that 0, 1, 4, 5, 6, and 9. These are the number. If you find that they are in the last digit of the number, then the number will be the perfect square. May or may not be the perfect square. May or may not be some, but may could be perfect square is 90%, but 10% may not be there. If this type of number means like 0, 1, 4, 5, 6, and 9. If this type of number are there in the last digit, they are perfect square, and the other numbers, okay, like you can get it 2, 3, 7, 8. This number are there in the last digit, then there will be no perfect square. That number will not be perfect square anymore. Once again, if you find a number having the last digit, the number as 0, 1, 4, 5, 6, and 9, these numbers are perfect square. Otherwise, the number with the other digits other than this digit I mentioned, those numbers will not be a perfect square. Okay, so in this way you can find out the answer of your question number 2. So I'm leaving for you, just you can practice for yourself. Okay, now let's go to question number 3. The question number 3, there are only two numbers given here, and one I will show you and one you can try yourself. See, find the square roots of the number 100 and 169 by the method of repeated subtraction. Means that you can see here, we have to find the square root by repeated subtraction. By repeated subtraction, we have to tell the square root of the two numbers. So I'm doing for you, okay? I'm doing for you. Now I will show this 169 how we find it. We have done in the example, but let's see here. See, first of all, you see here we have to subtract. We will repeat subtract, isn't it? That is step 1, 169. The first number to be subtract is the first odd number, yes, that is how much? 168. Then step number 2, 168 minus 3, then 165. Step number 3, 165 minus 5, then 160. Then 1 over 4, we have 160 minus 7, we get here 153. Then step number 5, 153 minus, next number is 9, this third number is 9, isn't it? Then how much we get here? We get here 140. Yes, 144 we get here. Then step number 6, 144 minus 11. How much we get here? 132. Then step number 7. That is 133 minus 13. That is 120 we get. Okay, step number 7, 120 minus 15. It is 105. Then here we have Roman number 8. Okay. So next we have 105 minus 70. And how much we get here? We will get here 88. We will get here 88. And next one we have is that we have step number 9. Okay. Step number 9, that is 88 minus 19. 88 minus 19, how much you will get? 88 minus 19, you will get that it is, yeah, 88 minus 69. You get here 69. After 69, we have again another step to be minus, isn't it? To be subtracted, isn't it? Yes. Then another we get here 69 minus 21. Yes, the next odd number is 21. Then we get here 48. Then 11. 48 minus 23. How much we get here? 48 minus 23. 48 minus 23 means you are getting here 25. Then what you will get here? You will get here that it is so here we have at 12 step number 12 we have 48 minus 23 is equal to 25. Now step number 13 we come here, that is 25 minus what? The next odd number will be 25, isn't it? Then we here 25, then we get here 0. So the operation is finished here. The subtraction is finished here to find out the square root of the number. So what we will get here is the square root of this 69. So we get here the 13th step. Isn't it? We get here 13th step, isn't it? 13th step we get here. 13th step we get here. So 13th step, this number 13 will take. So what happens? Square root of 169 is equal to 13. Is the answer. So this is the square root of the 169. Okay, clear? So this is the answer. So like this, you please do for this question, this number 100 also. Okay, it's not AB, but I'm just writing here AB. In your question, it's not AB. So in the question, you just these two numbers 100 and 169. 169 I have shown here. So for 100, please do this. Okay, clear? Let us go to the next question. So hello students, once again, now here we have another question. Here another question is question number 4. The question number 4 is asking to find the square root of this number by method of prime factorization. We know what is prime factorization. We have to find out the prime factors of the given number, isn't it? So we can find out the prime numbers of this given number, and it's called prime factorization. So prime factorization, we can find out the square root of the number also. How will we do that? Let's see. There are 10 questions. Okay, there are almost 10 questions are there. Yeah, there are 10 questions. So out of these 10 questions, I am showing only 3 out of these, and at least 2 or 3 will do by yourself. Please choose any 3 questions of them and you try yourself and do as a homework and give to me also. Okay, of this question number 4. Question number 4 will be as a homework. I'm giving you some more numbers that to try. I'm showing you here with some numbers, with some questions, and this will be same as for the other question also. So I'm showing you here how to find out the square root of the number here given in this question number 4. So here question number 1, number 4 and 6. Let's go. Okay, clear. So here first one is we have 729. 729 is to factorize one first. 729 prime factorization. So prime factorization, we have to go for the smallest prime factor, smallest prime number first. Smallest prime number is 2, but 2 is not possible to divide this, so we have to go for next prime number, that is 3, isn't it? So 3. So 3 3 2 is 6, yes, 3 4 is 12, 3 2 is 9 again. So 3 7 8 9 12, yes. 9. So 6 7 8 9 3 can go 3 yeah 3 3 8 is 24, yeah. 3 8 is 24, 3 1 is 3, then again 3 can go 3 2 is 6, 3 7 is 21, 3 again can go 3 9 is 27, and 3 3 is 9. So these are the prime factors of this number. So we have finished the prime factorization of the number given here, it is 729. Now we have to write like this. Square root. Already mentioned here square root, so please take square root of this number to 729. Square root of 279 can be written as like this. 3 into 3. The further of the factors 3 3. How many 3's are there? 6 3's are, isn't it? 3 into 3 into 3 into 3. So then what you have to do is you just pair 2 2. 2 2, why we have to pair? Because square root. Square in the sense that it is to be taken 2 2 number, okay, in the square. But if you come to the another chapter, that is cube root, then there will be another way. Okay, but here the way of this taking the square root is, after factorization we have to group 2 to like factors, means 2 to like numbers, 2 to same numbers, like 3 and 3, not 3 and 4, okay, 3 and 3, 3 and 3, 2 to we pair it, we group it. So each of them, each pair, each of the pair will take only one mark. So this also only one, into for this also only one, and for this also only one, and multiply them. Then you are getting here how much? You see, 3 3 is 9, 9 3 is 27, isn't it? Yes. 3 3 is 9, 9 3 is 27. So you get here 27. So 27 is the answer. 27 is the square root of the 727. So this is the answer we are getting by the prime factorials. Isn't it? Yes. So this is the answer for one here. Okay, for one. Now let's go for 2 here. Now we are going to not 2. For Roman 4, so we are going to do the same factorization. So let us see. Now we have here 4,996, isn't it? Yes. Yeah. So here you see, yeah, it can be start with 2. Yeah. 2 2s are 4, 0 down here, 2 4 is 8, 2 8 is 16. Still you can continue with 2, 2 1 is 2, 0 and 2 and 4 here, still 2 2 5 and 2 1 2 2. Still I can carry on with 2 2 2 is 4, yes, and 2 5 to 10, here 2 6 to 12, and again 2 we can go, 2 1 is 2, 2 2 is 4, 2 8 is 16. Still you can continue with 2 2 6 is 12, 2 4 is 8. Still 2 3 is 6, 2 2 is 4, and then still 2 2 1 is 2 2 6, and still get 2 is 16, and here still 2 4 is 8, and here we get it 2 2. So when we get the last number as the prime number, then we can stop here the division, isn't it? The factorization. So all these are the prime factors of this number given here, which is 4,096, isn't it? So you can just write like this: square root of 4,096 is equal to 2 into how many 2 was it? 1 2 3 4 5 6 7 8 9 10 11 12. 2 2 into 2 into 2 into 2. 2 3 4 5 6 into 2 into 2 into 2 into 2 into 2 into 2. So you group this 2 2 here. So how many groups are there, or how many pairs are there? 1 2 3 4 5 6. That means square root of 4,096 is equal to 2 into 2 into 2 into 2 into 2 into 2. Okay, so this all you have to multiply together. Then how much we get? 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32, 32 to the 64. So 64 is the square root of 4096. Got it? Yes. So this is the square root of the given number 4096. Okay. So we have to pair two numbers of the prime factors. So we have to factorize the number first, and those prime factors we have to pair two numbers. Like one, not unlike. Okay, not sometimes it will come like between 4 or 7, or maybe some other prime factors will come out. We cannot group unlike numbers like 2 and 7. 2 and 2, 7 and 7 we have to group, or we have to pair, and we have to take only one number and multiply all. Isn't it? Yes. Here we multiply all this number here for this 2, we have one here for this pair, we have one for this pair, so one, this pair, one, this pair, one, this pair. So 6 pairs are there, 6 2 are multiplied together, we get here 64, and 64 is the square root of 4960, 4096. Okay, so let's see for the next. So I set up this. So now we have the next for the question number 6. I'll show you the same way we have to take the final factorize. We have to factorize this. So let's factorize this. So we have to take the prime number 2 first. Prime number 2, 2 is a 4 here, yes. Means 2 4 is 8, 3 is 16, 0 down here 2. Then here we have here 2, 1 is 2, 2 to the 4, 2 4 is 8, 0, 1. And here, let us see whether it can be divided by 3 or not. Let us see whether it can be divided by 3 or not. You can see here 5, 6, 7. You cannot be divided by 3. 3 is possible. 5 is also not possible. Now, let's go for 7. So 7, here if you divide with 7, let's see how much we get here. 7 3 is 21. Isn't it? 7 3 is 21. If 7 3 is 21, then 3 will bring with the 0 and it becomes 30 here, isn't it? The 3 will bring here with 7 4 is 28 and 7 3 is 21. Then again, let us see it can be taken by 7 or not. So you can see that 7, yeah, 7 4 is 28 again. Yes, 7 4 is 28 and 6 will be 6 into 7 and 3, and we get here 7 7 is 47. So these are the prime factors of the number given here. So we can write like this. Since they asked to find out the square root, take the square root of this number. Square root is root over 9604 is equal to I'll just write here, okay? So then we get more space here. Square root over 9604 is equal to 2 into 7 into 7 into 7 into 7, 7 into 10. So this also must be on the top of this square, because already square root is there. Here also you use same thing here. Okay, but in the case of after you take one, you need to put the square root over it. After you have taken one, you need to put the square root over it. After taking, okay, clear. So here you see this can be written as root over this 2, this 2, this 2. Isn't it? That is 2 and 7 you cannot pair, okay, that you remember. 2 and 2 or 7 you can pair. So this can be written as 2 to the power 2 into 7 to the power 2 into 7 to the power 2 all. So with this square root and this square, and square root and this square, this square, all this can be cancelled, and we are getting here 2 into 7 into 7 here, and that the answer will be the square root of the given number. Okay. Okay, the square root of 9,604 will be 2 sevens are 7 sevens are 49. So 49 twos are how much? 49 twos are 98. So yeah 98. 49 twos are 98. So 98 is the square root of 9,604. See, the possible last digit of the square root having two digits, the square root having two digits here, the possible number in the last digit is 8. Why? Because you can see here 4. Okay. Ayah. 1, 2. So my dear students, so this is the answer for question number 4. So let us go to the next question, question number 5. Okay. Let's see. Hello student, once again here we have another question. The question number 5. The question number 5 is asking to find out the smallest whole number that can be multiplied. Means the smallest whole number or a whole number that will multiply to this given number so that they become perfect square. They are not a perfect square. The question is given here, the number given here in question number 5, they are not a perfect square. So they are going to what to say? They are going to make a perfect square by multiplying some numbers there, by multiplying a number. So that number we are going to find out. How we can find out? Let us see. What is the number missing there to multiply them so that they become the perfect square? So first of all, to find that, we have to go for the prime factorization. See, let us see here. Question number 1, we have like this. Number 1. Number 1 we have like this. So first of all, let us factorize this. 2, 5, 2 factorize. This 2, 1 is 2, 2, 4 is 2 2 is 4, and 2 6 is 12 here, and still 2 6 is 12, 2 3. Then here 3 3 2 3 1. Then 3 3 7 and 7 1. See, what we are not going to change. So here this is not a perfect square because here what happened, we cannot take here this 252 can be written as 2 into 3 into 3 into 7. See, 2 2 we can be group. We can pair 2 and 2, 3 and 3, but 7 is unpaired number. 7 is unpaired number. We need one more 7 here, so that if you get them, you will can pair them, and the number will become the perfect square. Okay, that means that is if we multiply the number, it is 252 by 7, then we will get the perfect we'll get the perfect square. Are you getting my point? So the number is 7. That means if we multiply 2, 5, 2 into 7, then how much we get here? 2 7s are 14. 1 in hand, 7 5 7 36. We have 3 and 7 2 0, 14, 15, 16, 17. We get here 7. Then is 1064 will be the number, so then we get the perfect square. That means this will be now becomes 2 into 3 into 3 into. So after multiplying with 7, then we'll get this. We'll get the perfect square. Okay. So this That means the square root of the number here, you will get here 2 into 3 into 7. Then we can get in here 7 to 21, 21 to the 40, 42. Isn't it? Yeah. So 42 is the square root of the given number. So then this number becomes the perfect square. If we can find out the square root of the number, then the number is perfect square. Then there is no need square root. You see, we cannot find out the square root of this number here because one number is unpaired. So if you find unpaired, then this will not going to find out, or you cannot find out the square root, and the number is not a square, perfect square. That's all. So like this, we can find out the number we multiply here, that we will get the perfect square of this number. Okay, this is also not a perfect square. We are going to see. Now let us see 1008. 1008. Yes. 2, 5 are 10, 0 will get here, and 4 here, yes. Then 2 still. 2, 2s are 4, and 2, 5, and 2, 2 still will get here. 2, 1, and 2, 5 will get 7. 2, 6, now 2, 6, 3, then 3, 2, 1 here, then 3, 7, 8. So here also you can see. So here you can see here, we can group 2 to here. For example, here 1008 can be written as the product of prime factors 2 into 2 into 2 into 2 into 3 into 3 into 7. So these two, they can be paired. They can be paired, they can be grouped to find out the square root of the given number. But we cannot find the square root of this number because it is not a perfect square. If there is no perfect square, we cannot find out the square root of it, isn't it? Yes, we cannot find out the square root of this number which is not a perfect square. That means, see, when we go for finding out the prime factorization, and when we try to group two numbers of the same number, 2 and 2, 2 and 2, 3 and 3 like this. So now one number that is 7 becomes as an unpaired number, isn't it? That means it's not a perfect square. So to make the perfect square of the number, then we have to multiply with 7. So the required number is 7. So the required number is 7 to multiply to the number to get the perfect square. That's all. Here I just make it little expanded. Now you can sort of like this. Keep it. Likewise, here also you can see this 768. 2 3s are 6. Yeah, 2 3s are 6. 2 3s are 6. Then 2 3s are 6. Then 16 8 will be here 4. Then 2. 1 is 2. And 18 2 9s are 18. 2 2s are 4. Still 2. 2 9s are 18. And 2 6s are 12. Still 2. 2 3s are 6. 32. Then 2 4s are 8. 2 4s are 8. 16 48. Isn't it? Then 2 2 4. Then 2 1 2. Then 2 6. Then 2 2. So the number here can be expressed as the product of its prime number, like this. 7 6 8 is equal to 2 into 2 into 2 into 2 into 1 2 3 4 5 6 7 1 2 3 4 5 6 7 8 that. And 3 here, 1 3 is there, isn't it? 3. So this can be paired. All the 2 can be paired. 2 we can pair, but one number you can find out there 3 which is unpaired number, isn't it? So because of this unpaired number, we cannot find the square root of the given number, and the given number is also not a perfect square. So to make a perfect square, we need this 3 to multiply again, one more 3 to multiply, so that we get one more 3 and we get the perfect square, isn't it? Yeah. So the required number to multiply to this number is 3. The smallest whole number to multiply here is 3, so that the number can be a perfect square. So the required number is 3. This is what? Okay, so we get here 3 is the number to multiply here, so that the number become the perfect square. Understand? So like this we can find out the other also. So please, other 3 questions are there. You can try yourself. Okay, please put yourself in practice to find out such problem or solution of such problem in your books. So for today here I want to end the session, and we'll meet again in the next video. Okay. So before I go, I want to just remind you, my dear student. So there are 2 methods. There are 2 methods we are discussing now, right now, to find out the square root. First one is prime factorization, and second one is your repeated subtraction. Repeated subtraction and your prime factorization. Prime factorization, you know that just to find out the prime factors of the given number, isn't it? If you can group 2 to 2, then they are perfect square. If you cannot group 2 to 2, if you find that one number is unpaired, then it is not a perfect square, and also we cannot find out the square root. To make it perfect square, we need to multiply with the number. What is the number that unpaired? We have to multiply the same again to the number, then we get the perfect square. Okay, and another method for finding out the square root is repeated subtraction. So what we have to subtract from the number? A number will be given there. A number will be given there as a function. From that number, we have to subtract continuously. Okay, all the consecutive odd numbers. All the consecutive odd numbers should be subtracted again and again continuously. Then that you get the 0 as the answer, 0 as the difference. Till you get the 0, you have to minus and minus and minus. Go on minus. Okay, clear? All the odd numbers from the given number again and again and again. So that you get the last is 0, and how much steps are there, that will be that number of the step will take, and that will be the square root of the given number. So this is what for today. Okay, clear? So here we end for today's session, and we'll meet again in the next video. Till then, have a nice day. Okay, so thank you once again for watching me. Bye bye.